Hey everyone, today we will solve problem number 858 from the LeetCode, that is mirror reflection. This one is a medium level problem and it is a kind of maths problem. So let's check out what is the problem. There is a special square room with mirrors on each of the four walls. Okay, all the four walls have mirrors uh, and except the southwest corner, there are receptors on each of the remaining corners. Okay, there are four corners in the room and except the southwest corner, all the three other corners have receptors for the rays. Okay, this corner will transmit the light and these three corners have some receptors, and the, it is the case that at least any one of the receptor will accept the light, receive the light. Okay, so let's check out this from some examples. This is the example when P equals to 2Q. This is P they have given and Q. Okay, so light will go from here and it will reach here. This is the zeroth receptor, first receptor and second receptor. Let's check out here. Light is, this is Q and P. Okay, P equals to 2Q. P equals to 2Q. Now light will first reach here, then it will again reflected back because this is a mirror. Mirror will reflect the light back. Now it will reach at 2 we have receptor, so it will reach 2 and 2 will accept the light, receive the light. Okay, as we know that angle of incidence is equals to angle of reflection, so this is just a light property that it will reflect back with the same angle. So from this what we have noticed that if m is 1 and n is 2, that is n is even. If n is even, then light will reach at 2. If n is even, then light will reach at 2. This is the equation we have formed for this problem, that m into p equals to n into q. Q is the length from the corner at which light is reached and p is the length of the wall. So let's check out one more example for reaching to. Here I have taken P equals to 4 times of Q. Okay, so light is passed from here, as I said that P equals to 4 times of Q. So at this, light reached Q, Q and Q. Okay, so it will just reach and reflect back and reach at 2. Here also we have noticed that n is even. Okay, so what we have conclude from this two examples, that if n is even, then we are reaching the second number of receptors. Second case we will check for reaching 0, how we can reach 0. Okay, so here I have taken one example. P is 3 and Q is 2. Light will be passed from here, so it is like this is 2 and somewhere here. So what I have made is a imaginary, that I just uh, made an imaginary mirror with the same, so that light will come like this. Okay, it will come like this, but it is easy to visualize with the another way. So this complete length will become 2 and then light will again reflect back from here to here and it will reach to the receptor 0. Okay, this will also 2 incident here and again reflected back, and it will reach 0. So what we have noticed, that here n is odd, n is odd and m sorry and m is odd and n is even. Okay, that's how it is reaching 0. Now let's check from the code that you will understand. First I have initialized m equals to n equals to 1. Then for I have just checked that this condition, that if p into m is not equals to q into n, I want, what I want to do, I want to find the value of m and n, and for the condition, for this condition, that p into m should be equals to n into q. So for this condition I have to find. So if it is not equal, then I just increment n. Okay, I will increment n, I will find m value. When this will be true, then that n and m value will be final. And we will, if n is divisible by 2, then we will return that, we will conclude that the ray will uh, received at the second receptor. Okay, if n is not divisible by 2, it means that if n is not even, then we will check m. If m is even, then we return 1, else we return 0. Thank you.